All right, in example 4, we're going to look at how we apply the properties of algebra. All right, so let's take a look at these properties of algebra. We're going to start with the commutative property. The commutative property, I like to think about it as we've got the word commute in there. And you're commuting to and from work, going to work, you're coming home from work, and you're switching your order, you're changing where you're at. So the commutative property, I always like to think about this as it's the order. All right, so let's take a look at examples of that. So the commutative property of addition, we would have something that is switching up the order of the addition. So for example, you could have A plus B is equal to B plus A. And now let's go ahead and let's put some numbers in there. We could have 3 plus 4 is equal to 4 plus 3, because we know that 3 plus 4 is 7 and 4 plus 3 is 7. It didn't matter which order we added these in, they're both going to result in the answer 7. So again, for multiplication then, we're looking for the order. So you could have A times B is equal to B times A. And let's throw some numbers in there. So 3 times 4 is equal to 4 times 3. 3 times 4 is equal to 12, and 4 times 3 is equal to 12. All right, so let's take a look then at the associative property. The associative property, I like to think about that as we associate ourselves with a group. So the group we might associate ourselves with is Kenwood Trail. It might be a Boy Scout group or a Girl Scout troop, something that we associate ourselves with. So this is our grouping. All right, now let's apply that. So what do we mean by that? So it could be something like A plus B plus C, and I might have a parentheses around A and B, meaning I have to add those first and then add the C. And then we could have A plus B plus C, meaning here I'm going to then, I'd have to add B plus C first. So it's the grouping. The numbers are staying in the same order, but we've just put the parentheses in different places. So let's take a look at what that looks like with some numbers. So I could have 3 plus 4 plus 5, and we're going to put parentheses around the first set, is equal to 3 plus 4 plus 5, and I'd have my parentheses around this here. So let's take a look at that. 3 plus 4 is 7. 7 plus 5 is 12. All right, so, and then let's look at the other side. We'd have to start with the 4 plus 5, which is 9, and 9 plus 3 is also equal to 12. Now the same property works for multiplication. I could have A times B times C, and we'll go ahead and do that, is equal to then A times B times C. All right, so let's do our numbers again. 3 times 4 times 5 is equal to then 3 times 4 times 5. All right, so 3 times 4 is 12. 12 times 5 is 60. And let's look at the other side. I would have to do the 4 times 5 first. 4 times 5 is 20, and 20 times 3 is also equal to 60. All right, so the identity property. All right, the identity property, I like to think about this as you're going to keep your identity. So you're going to stay who you are. So I'm just going to write a little note over here to remind ourselves that we're going to keep identity, maybe your. All right, now we should probably talk about the additive identity and the multiplicative identity too in just a minute here. But this one we're keeping our identity. So what that means is if I had, for addition, we have to think about what number could you add to yourself and stay yourself. Well, I could have something like A plus, well, that number is 0, and it would stay an A. And I could look at something like 4 plus 0, you're going to remain the number 4. I've added 0. So the additive identity is 0 because you can add 0 to any number and you're not going to change the value. All right, so let's take a look at what it looks like for multiplication. So let's think about what you could multiply by yourself to stay yourself. So if you're a 4 and you want to stay a 4, you would multiply yourself times 1. So we say a times 1 is equal to a, or we could have 4 times 1 is equal to 4. And so the multiplicative identity, because you've multiplied yourself to stay yourself, that's going to be equal to 1. All right, now the inverse property. Inverse is kind of what undoes something. It's the opposite. You would undo. So you're going to undo an operation. So for addition, to undo a number to addition, we would be looking at the opposite of positive is negative. So I could have something like a plus negative a is equal to 0. Or I could have 4 plus negative 4 is equal to 0. Notice how the inverse property gets you back down to this additive identity. So it's equal to 0. All right, so then we're going to multiply ourselves then to undo. So if I had something like a times the inverse is, which is 1 all over a, then I could multiply. I would have a times 1 is a, 1 times a is a divided by a is equal to 1. We're getting down to that multiplicative identity. Let's take a look at what that looks like with numbers. I could have 4 times the inverse, or the reciprocal, is equal to 4, 1 all over 4. So I'm going to have 4 all over 4, and that is equal to then 1. So notice it undid it. Now we got back down to that multiplicative inverse, identity, which is 1. All right, our distributive property is the last one that we're going to talk about. The distributive property is basically where you could have a times b plus c is equal to then, and remember what we're doing, we're multiplying both parts. Both parts get handed out that a. That's going to be equal to ab plus ac. All right, let's take a look at what this looks like with the numbers then. I could have 3 times 4 plus 5, and that's going to be equal to then, I'm going to multiply these both. I get the 3 times the 4, they both have to be multiplied by that, plus the 3 times the 5. Now you're going to usually see that by using variables in there, and so a lot of times you don't see it that way. But let's take a look at the left side. I'd have to start by taking 4 plus 5, which is 9, and 9 times 3 is equal to 27. If I look at the right side, I'd have 3 times 4 first, which is 12. And then I'd have to have 3 times 5, which is 15. I'd add those together, and I would get 27 there as well. All right, so let's go ahead and take a look and identify these properties being illustrated. Number 1, we have negative 15 plus 0 is equal to negative 15. Notice how I start with the negative 15, and I'm adding something to it, and I'm remaining the negative 15. Remember, when that happens, you're remaining yourself, you're staying yourself, so that is the identity property of addition. All right, and looking at our next one, we have number 2, we have 9 plus negative x plus negative x plus 9. So in this case, notice how we have the 9 and the negative x, they've switched the order. Remember, anytime you switch the order, that's the commutative property. And so in this case, because we have addition, this is going to be the commutative property of addition. And number 3, we have 5.1 plus negative 5.1 is equal to 0. Notice how the 5.1 and the negative 5.1 have canceled each other out, leaving us with 0. and 0 is that additive identity. So in this case, we have the inverse property of addition. Number 4, we have 12 plus negative 17 is equal to negative 17 plus 12. Again, in this case, we have switched the order of our numbers, and so this is going to be the commutative property of addition. Number 5, we have 3 plus negative 2 in parentheses plus 1 is equal to 3 plus in parentheses negative 2 plus 1. Notice in this case we've left the numbers in the order they were in, but we've switched the parentheses. Remember, anytime we regroup something, we join another group, that is the associative property. So in this case, it's the associative property of addition. And number 6, we have negative x plus x is equal to 0. Again, we've canceled out those x's, leaving us with that additive identity 0. So in this case, because what we've done is we've done the inverse, the opposite. This here is the inverse property then of addition. All right, so now we're going to identify the multiplication properties that are being illustrated. So our first one, let's notice, I have x times 5 and then I have 5 times x. Remember, when you switch the order, that this is a commutative property, and because then I have multiplication here, it's going to be the commutative property of multiplication. All right, so let's take a look at number 2. I have a times b times c, and then I have a times b, then times c. Notice how the order stayed the same, but what we've changed is we've changed the grouping of that, of what's being multiplied. So remember, when we deal with grouping, we are looking at the associative property. So this is going to be then the associative property, and then it's of multiplication because I have multiplication in my problem. All right, for number 3 then, I have 5 times 1 is equal to negative 5. All right, so what I've done then is I have multiplied myself by a number, then I'm staying the number of negative 5. Remember, that is then the identity property, and because I have multiplication, this is going to be the identity property of multiplication. All right, number 4. I have negative 3 times x times 2, and then I have negative 3 times x times 2. Now notice that the order remains the same here, but what we've changed is we've changed the grouping of it, meaning I would have to do negative 3 times x first, then times 2, and where on the other side of it I would take 2 times x, and then I would multiply that by negative 3, resulting in the same answer. All right, so I'm going to have then the associative property of multiplication. All right, question number 5. I have negative 2 times 4, and I have 4 times negative 2. Notice here that we have the order has been switched. And so in this case, then it's going to be the commutative property of multiplication. All right, number 6. We have 3 times x minus 4 is equal to 3x minus 12. Now in this case, what you'll notice here is I've taken 3 times the x, and I've taken 3 times negative 4. When I took 3 times x, I ended up with 3x. And then when I took 3 times negative 4, I got a negative 12. Remember, in this case, this is called the distributive property. All right, number 7. I have 3/4 times 4 all over 3 is equal to 1. So notice how for this one, we multiplied it by its reciprocal, or its inverse. So this is the inverse property of multiplication. And see, we got back down to that multiplicative identity. The next one then, same thing. We've multiplied 16 times 1 all over 16. And so you'd have 16 and have 16 equaling 1. So when you multiply by its reciprocal or by its inverse, remember again, this one is also the inverse property of multiplication. So in this lesson, we took a look and identifying the properties of addition and multiplication.